Read all your Parvaderm cases and monitored your discussion, and you should all have your grades by now. And I wanted to go over some of the things that basically all of you didn't look at in the case. Your answers were fine, the final conclusions were fine, but I didn't see them supported by anything more than, well, I think this is the best thing to do, or something like that. So subjective support for what you wanted to do and some very good reasoning as to why you wanted to do that. But in a case like this where you've got a lot of data, you need to use the data to support your decision making. And a few of you used a little bit of the data, but most of you ignored most of the data. And I'm not being hypercritical here. I've taught this course both in person and online for many years, and taught people how to do case studies for many years. And in general, the very first case study that I assign, people tend to, first of all, accept everything in the case as, let's say, gospel. And also tend to ignore the potential for analysis of the data they're given. So it's possible to take the data you're given in a case, and you really, in Ms. Masters' position, you've got all of this data. What do I do with it? And it's possible to take the data and use that data to help you make a decision, and then once you've made a decision, to provide a justification for your decision. Generally speaking, when you're making business decisions, you make the decision, but you're probably not the final arbiter of that decision. You probably have to defend your decision to someone who's in a position of authority, or someone else who has decision-making power. So, for instance, if I want to make a decision in marketing, I can make a very solid, good decision, but then I probably have to sell that decision to both the executive, CEO, whatever that person, but also to the finance department. How do I sell my decision to the finance department? How is this a good decision or a bad decision? Is it going to be self-supporting? Is it going to generate additional marginal revenue? What's it going to do for me? Is what the finance person is going to ask. The CEO is going to ask whether it fits in with our overall long-term strategy. So you need to be able to defend your decision to those people. And Ms. Masters would have to do that as well. So what I've done is I've put together an Excel sheet, which I will also post to Canvas, so you can look at it, and you can also look at my formulas. But I put together an Excel sheet taking some of the data, not all of it, but some of the data, and using it to provide some analysis. And you could use this analysis to support your decision process, and I think you could find it somewhat helpful. The next case that you get, which will be at the beginning of next week, also will require you to do some data analysis. I didn't take a lot of points off your reports this time for the lack of analysis, let's call it. But next time I will. So use this little exercise video here to inform yourself on the kinds of things you can do. And the next time you see a case, you'll be able to use some of the numerical data that's provided to justify whatever decisions you might make. So I'm going to disappear myself here so that you can see the whole spreadsheet. So what I've done here is I've put the retail price of the current tube that was provided in the case, and they told you that the retailers get a 40% margin. So that means that the retailers are paying 40% less than $3.95 for the product. So they're paying $2.37. And then the jobbers, they didn't really explain what a jobber is, a rack jobber. But a rack jobber is very common in the grocery store business and in the drugstore business. And rack jobbers sell the product to the retailer. And that might be a retail chain, or it might be a single retail outlet. And what the rack jobber does, they make the sale, so they get the product, the retailer to carry the product. They negotiate the selling position within the store, and then they have people who work for the rack jobber go to the stores and actually keep the product on the shelf where it's supposed to be and keep it stocked. So they do some of the work that the retailer might have to do themselves if you didn't have a rack jobber. And for that, they get a relatively high commission, in this case, 20%. So the wholesale price that the retailer pays is $2.37, but the amount that Parvaderm gets is 80% of that, because they're going to pay 20% of that to the rack jobber. So they end up getting a sale price of $1.90. You can confirm that. They give you the information in the case that the sales for 2005, I think, I don't remember the year, 2005, were 3,724,000, and they sold 1,960,000 units. If you divide that, you'll find out that that comes to $1.90 per unit. So this is where the $1.90 comes from, and it's confirmed within the case that that's what their sales were, and that's how much they were selling per unit. Retail margins are always computed that way. You'll see them in other cases. You'll probably see them in your business career. Retail margins start at retail and then back down to wholesale and then back down to net. So when you have a retail margin of 40%, it's 40% of the retail price. And then a commission for a salesperson, whoever that might be, a rack jobber or other kind of salesperson, will be based on the price they're selling it at. So if they're selling it at $2.37, in this case, they've got a 20% margin, a 20% commission. So that Parvaderm is going to pay them 20% of $2.37, and Parvaderm will only generate $1.90 as revenue. So if you take the $1.90, you subtract the cost of the product, you get to 59 cents. Let's see, hold on a second here, we're missing something. There we go. Variable cost including freight, fixed marketing cost. They tell you that's a fixed cost in the case. That gives you a contribution to overhead of 91 cents, and that's a key number. The allocated overhead is a bit of a red herring. The allocated overhead doesn't really help, doesn't really apply directly to this particular product, this soft and silky. It applies to taking the overhead for the factory and taking their share of it, probably based on their sales numbers, the volume numbers. So if you take this number out of here, that 21 cents is going to have to be allocated somewhere else. So I'd look a lot at contribution margin as your key number here. The other thing that they provide you with is they provide you with the size of the market. They tell you that the total market's 550 million at manufacturer's sell price. They tell you that the percentage for creams and gels is 126 million, and Parvaderm has a relatively small market share of just under 3%. So that tells you something and may help inform your decision, and you can use that as you will. The other questions I have is there data to back up the assertion that aerosol is a dominant design? There's lots of anecdotal evidence of that, but I didn't see any hard data on that. And one way to get that hard data was, is there sales data available of various package designs currently on the market? They didn't provide you with that. That would be a question that Ms. Masters might want to ask. Can't we get sales data on the various package designs? So we know what percentage of the market is aerosol, what percentage of the market is creams, what percentage of the market is pumps, whatever else is out there. They gave you some probabilities in the market research. And I'm going to go through that, and these are this is my summary here, so I'm going to go through how I got to that. So let's just back over here. So first of all, you have to convert the market forecast to units because we don't care about ounces. Ounces don't matter. We're selling units, so we have to convert the items to units. So under forecast A, given in the case, the tubes converted to units, and if you look at this, it's 8.6 million ounces divided by 5.5 gives you units. And then we know we're going to sell them for $1.90, so that's that times $1.90. We know what our variable costs are, and I just took it to gross margin in this analysis. So I didn't look at the marketing costs. I just said, what's the gross margin? So we're going to have a gross margin of 2.3 million under forecast A. Also under forecast A, we're going to sell 444,000, which is the 202.5 million divided by 5.5. We're going to sell 444,000 units of the aerosol. We're going to sell those for $1.68, which is 0.6 times 3.5, which is the retail price, times 0.8 for the rack jobber. $1.68. Sales at wholesale is $746,000. Variable cost is 24 cents, which is the cost to deliver, and gross margin of 640. So those two things, if I do take forecast A, I'm going to make $2.3 million on the old product. I'm going to make $640,000 on the new product. Total gross margin of almost $3 million, 2.985. And there's a 30% probability that that forecast will come out. So they give you all that information. You need to use it. And then forecast B, same type of data. We're going to sell somewhat less. This is if we introduce the this is the low estimate, and this is the, let's see, low or high. This is the low estimate, and this is the high estimate. So same kind of information. High estimate, we're going to have a little bit more cannibalization, but we're going to sell more units of the new packaging, and we're going to make 3.03. So we're going to make a little bit more, and there's a 70% probability of that happening. So here under probabilities, the likelihood if we introduce the 5.5 unit aerosol and keep the tube, this is what our profit number should look like, given these two probabilities. So that's a number that we can run with. Is it absolutely accurate? No. But does it give us an example of what might happen? And then forecast C and forecast D include putting in the 10 ounce aerosol. And I've done the same thing. I'm not going to walk through each item, but I've done the same thing. And here, this should generate 3.4 million using those same probabilities. So we've got two numbers that help. And then we know that currently tube only is going to generate this because they've given you that number. So that's the number there. So we know if from a dollar standpoint, if their estimates are correct, the most profitable item is going to be forecast to do the 10 ounce product. And most of you came up with that as a solution, but you don't have the data to back it up. So here's your data. Use the data that's given you. So the tube has a gross margin of $1.50 per. The 5.5 ounce Aero has a gross margin of $1.44 per unit, and the 10 ounce Aero has a gross margin of $1.75 per unit, with 3 different percentage rates. But really, we're dealing with units and gross margin. Those are the things we care about, because that's the driver for what we're doing. So now, If we go back up here, there's some fixed costs that you have to take in. The lower sales of tubes will not lower the marketing or overhead costs for tubes unless the factory overhead can be absorbed by the production of other items. The factory is at full production, so this might be possible. And several of you mentioned that. We might be able to use the additional space that we generated in the factory to produce other products that might be more profitable in this. So we've freed up factory space by outsourcing to aerosol, and that may be a benefit. We probably don't have the numbers to figure that out, but we can say that that's a possibility. So I'm not telling you what the right answers are here. I'm just giving you some tools necessary to figure that out. And I will talk a little bit when I assign the next case. I'll talk a little bit about how you need to use the numbers in the case to both help you make decisions and also justify those decisions once you've made them. So that's my thing for today. Good luck with your quest, which is due this week, and I'll talk to you next week. Bye.